Today we are going to talk more about solving equations. So far we've talked about how to use properties of equality to show and organize your work. We've talked about how to deal with having a variable on both sides of the equation. What we're going to look at today is some longer equations similar to what you are looking at on your screen right now. We are going to actually use this equation as an example equation. So this equation looks kind of long and scary, but it's actually not too bad if you know what to do. So this equation boils back down to an equation similar to what you were working with yesterday that would be a basic variables on both sides equation. So most equations, if you know how to handle them, they can be reduced back down to an equation like you were working with yesterday, or even a two-step equation in some cases. So we're going to talk about how do we take this big, slightly scary looking equation and make it not so scary looking. One thing you have to remember is that an equation is actually two different expressions that have been joined together. So we have one expression on the left side, and we have a different expression on the right side. So if you're going to work with a big equation like this, before we're ready to actually solve the equation, we need to do some simplifying. So our first step, which I'm actually going to write off to the side so it's not in the way of our work. So our first step is going to be to simplify each side or each expression. So this is also a good chance to review simplifying. So simplifying is actually a two-step process. So if you have parentheses like we do on both sides of this equation, we need to deal with those first because order of operations tells us to. We also need to deal with them because the variable we're trying to get, some of our x's, are inside those parentheses, and we can't just rip them out of the parentheses without violating order of operations. We do have a property that will let us get to those variables in the parentheses, though, without violating order of operations, and that is distributive property. So if we're going to simplify each expression, the very first thing that you want to do if you have any parentheses like we do is to do some distributive property. Again, I'm working in the corner of the screen with our directions so that we could show the steps here. So we're going to go ahead and do this first step, which is just to take each thing and rewrite it with distributive property. And I'm actually going to work with the red side and the blue side at the same time. Because it makes sense if you're doing the same step with both expressions to go ahead and do that step everywhere where you can. So there's two different places where we have parentheses so we can use distributive property. Once on the left side and once on the right side. So we're going to go ahead and do that. So 3 times 4x is 12x. And 3 times 1 is 3. And then we need to not forget that we still have this minus 9x hanging out there. That's part of that expression. So that's still going to be on the end of what we rewrote with our distributive property. So we need to not forget about that other piece that's after the parentheses. On the other side, if I do distributive property again, 6 times 2 is 12. And then this is minus 6 times x, 6x. So that is our first step, distributive property. The second step for simplifying, so use distributive property where you can. And the second thing is to combine like terms. So as a reminder, so things that are like terms, if something's a like term, that means it needs to have the same variables in order to be able to be combined, and the same power with those variables. So we don't need to worry so much about powers here because we don't have any exponents in this equation, but we do need to look for things with the same variables. The other thing that's really important to remember when you're doing this is that we are working with two different expressions. Don't forget the red expression on the left the blue expression on the right. So the red expression pieces need to stay with the red expression, and the blue expression pieces need to stay with the blue expression. So we should not be taking any red pieces and trying to put them with any blue pieces. There are no purple pieces. Red stays with red, blue stays with blue. So this equal sign really you can kind of think of as like a wall. Things can't pass through the wall. So we want to look for things within each expression, just the red expression or just the blue expression that we can combine. So the red expression, we do have some like terms because I have this 12x, that has an x. And then this minus or negative 9x, that also has an x. Those both have the same variable, so I can put them together. So 12x minus 9x is 3x. And then we also need to not forget that we still have this plus 3 there, so that needs to be rewritten. So that is what the red expression looks like simplified. We did distributive property to get rid of the parentheses, and then we combined our like terms. The blue expression is already simplified. There's nothing else that we can put together in that expression. So that one we would just rewrite just to keep things balanced on the same line of the equation. So now this equation is simplified. We did our distributive property. We combined our like terms on each side where we could. And this equation hopefully is looking familiar. It now looks exactly like the equations you were working with yesterday. So from here, we could pick up our steps from yesterday and quickly zip through those steps to finish the equation. So we're going to go ahead and do that quickly. So I'm going to choose to get rid of the negative 6x. So I'm going to do that by adding 6x to both sides, addition property of equality. That gives me 9x plus 3 equal to 12. And remember, every time you use a property of equality, rewrite before you do anything else. Subtraction property of equality, that's going to give me 9x equals 9. Division property of equality, 9 divided by 9 is 1. So this whole big long equation, and we got x equal to 1. We can go back to the beginning of the equation too and check our work. So if we fill a 1 in everywhere where there is an x, we can test that out. So 4 times 1 is 4. Plus 1 is 5. 3 times 5 is 15. And then we also need to drop a 1 in here. 9 times 1 is 9. So this is going to give us 15 minus 9, which is 6. So that whole side of the equation gives us 6, the red side. Now if we come over to the blue side, 2 minus 1 is 1 times 6 is 6. We got 6 on both sides, so we know our answer is correct. So that is how you deal with a longer equation. Simplify each expression first. The way you do that is by doing distributive property first and then combine like terms. And then from there, you can move on and you can solve the equation just like you normally would.